I'm Seth Larson. I've been working at Elastic for a few months now. I'm a software engineer. I do a lot of maintenance work on the Python clients specifically for all the different services that Elastic offers. And one of those clients is Eland. And so that's what I'm going to be introducing today. This is kind of the logo. And so this project, if you're interested in the project, if you want to follow along or something like that, you can install it from the Python package index. And it's also available on CondaForge. It supports specifically Elasticsearch 7.6 and later. Source code's available on GitHub under Apache 2.0 license, and all the docs are on Read the Docs. So why do we build Eland? We really wanted to basically provide a familiar API for users of Pandas and other data science libraries like scikit-learn, XGBoost, NumPy, libraries like that where there's a really deep familiarity with those libraries and those APIs. And we wanted to be able to provide those APIs so that users familiar with those APIs can visualize and explore data that's in an Elasticsearch cluster. Also, we're really interested in the ability to have Elasticsearch essentially be a backend for like a big data use case. So if you have, petabyte scale data sets in Elasticsearch, how can you use Eland and Python specifically to visualize those massive data sets without having to overload your machine? So one of the big benefits of Eland is that instead of in the traditional sense in Pandas, when you have data in a data frame, it's all on your machine, whereas that's not necessarily beneficial if you're using a big data use case. So how can we provide the same APIs as Pandas, but instead of having everything being in memory, have things be computed and stored actually in Elasticsearch? And then there's a lot of utilities that make uploading data sets. Commonly, a lot of tabular data that you receive. Sometimes it's kind of tough to upload that directly into Elasticsearch. And so Eland kind of provides some connectors and utilities there for uploading large data sets. So why the name Eland? So Eland in Dutch is elk/moose. And so as you know, like elk stack is kind of something big in the Elasticsearch space. And so it was kind of fun there. And then elastics and data is kind of like if you imagine ELA, the N and the D for Eland. And then there's also a street near the Elastic office that kind of has it as a prefix. And so the name itself, the pronunciation doesn't matter too much, but the pronunciation, and I'm not going to like attempt the exact pronunciation, but Eland is more close to what the actual pronunciation would be. And then as is really common in especially in the data science space, the import that you'll typically see for Eland is import as ED. So Pandas will have import as PD. And so we wanted it to be able to be mirrored as ED, PD. And so that's kind of a familiarity there. OK, so let's get started with the bulk of what this talk will be about, which is data frames. So Eland's primary API is a DataFrame API. And so what that data frame will do is it maintains essentially a query builder and a task graph internally so that you'll be touching a DataFrame API and building on that incrementally the same way that you would in Pandas. But instead of actually having those processes and tasks execute immediately on local data. Instead, what it'll do is it'll maintain a task graph in the same way that Dask, if you've heard of Dask, would do. So it's very similar concept. And then once data is requested, so if you say, OK, now I want to see my data after I've done all of these manipulations on this data frame, then the query will be executed and pull from the Elasticsearch cluster. And then the data will be put into a data frame the same shape and size and data types and everything that would have happened had you done those exact same manipulations on a local Pandas data frame. So because a lot of the Pandas API is kind of not compatible with what would traditionally be done with an Elasticsearch query, things like I want to know the like exact document at this exact row of an index. So that's not exactly like a super efficient or meaningful statement in an Elasticsearch cluster. We wouldn't implement that subset of the API, but you'll find that actually a lot of the API is implemented. So things like filtering, aggregations, comparing rows to themselves within queries. There's actually a surprising amount that you can implement in Elasticsearch, and there's still some that we need to implement. So there's that. And then there's also like an API that you can essentially, if you get to a point in your query where you can no longer implement the APIs that you need, you can always call this toPandas API. I'll show that to you a little bit later, where it'll essentially just do the pull for you, and then you can continue along your way with other APIs. So yeah, like I said, the last data point, results are returned into the Pandas data structure. So what this library kind of logically does is it maps these concepts that are traditionally Pandas concepts and maps them into Elasticsearch concepts. So a data frame is analogous to an index, and then a row would be a document, and a column a field, etc. So one thing that's really helpful is our mappings between the data types and mapping types. So when you have Elasticsearch obviously has a lot more richer types than the basic types of Pandas. And so there's a lot of work that's done to make sure that the mapping types on the Elasticsearch side are still usable from Pandas side, etc. So because this data frame is backed by Elasticsearch, we also like extend the Pandas API a little bit to provide a way to use those extra features of Elasticsearch. So obviously Elasticsearch is known for its querying. And so having special filters for things like full text search or geospatial, or a lot of people have analyzers, or being able to sort by relevance. So if you make a query and I want it to be sorted by the relevance, that's possible. So this magical method ESQuery essentially lets you have the full scope of Elasticsearch querying and filtering, and adds that to the Dataframe API, and it works completely seamlessly with all the other Pandas APIs. And I'll be showing a demo of this a little bit later as well. This is a pretty demo-heavy talk. So the utilities for importing and exporting data or other tabular data to and from Elasticsearch. So one of the challenges of, especially if you have like really large data sets in a CSV or something like that, instead of having to write this custom uploading code yourself, instead of doing that, you can use these utility functions that we already provide. So you can load your data set and then do your manipulations locally, potentially in like a streaming fashion, and then call pandas to Eland, and it will upload, either create an index, or if you've already have an index there, it will append to that index. And then you can provide overrides. So if you have specialized types like geospatial points or IP addresses, like if you want to have additional functionality on those points, you can provide those overrides to this function, and it will create an index properly. And then you can also go the other way, where if you have an Elasticsearch index and you want to pull it down to be tabular data, you can always pull it into its own like Pandas data frame instead of an Eland data frame. And then the warning on the bottom there is just be aware that when you call these functions, you're essentially asking the cluster to dump everything that would match that query. So if it's an empty query, it will match everything. So that's something to be aware of. You probably don't want to dump your entire cluster into your local memory. So just be aware of what you're doing here. And there's lots of methods to make it so that you can, for example, pull a sample of your data. So if you're just trying to, oh, I only want 10% of my data, but just give me random data points just to do some experimentation, you can always do that. There's the sample API for Pandas. That works just fine. That's definitely a lot safer to do than just dumping your entire cluster. So just be aware that when you're doing that, you are dumping everything to memory. Okay, so first demo. Let's see how easily this works. Okay. All right, so here I have a Jupyter Notebook, and it is currently backed by an Elastic Cloud instance running with a machine learning, and I'll actually give a quick demo on how to set that up. So this instance just so I can show how it was actually set up. It's very easy to use Elastic Cloud to set it up. Here's the instance that's running right now. I apologize if the text is a little small. So you're going to give the deployment a name, and then select your cloud platform and region, select your version. I always recommend the latest. This is fine. And then what you'll do for the machine learning instance specifically is you'll go to customize deployment. And then you can kind of, if you want to change some settings here, like if you want additional zones or something like that, that's totally fine. And then for machine learning, you're going to hit enable, and then choose your RAM settings, whatever you need for your project. And then you can change some additional settings here. And then you just can hit create deployment. It takes just a few minutes to create a deployment, and then you'll be running with a equivalent instance to what I'll be using here. So I have my password saved in a text file so that it's not dumped to the screen. And then I also have this cloud ID, which it will hand to you right when you start the instance, essentially. So you just copy and paste that here. And then you'll see that it's used down here with cloud ID going directly into the Elasticsearch index, and then the password going into HTTP authentication. And you can also use an API key if you want to create an API key. That's totally fine. OK, so this is just setup. Here's some basic imports. You can see Eland is imported there as ED. And then I also have a function here just so I can pretty print some JSON. And so it doesn't like just shoot off to the side if it's a really long document. That'll be used a little bit later. So let's start running these. OK, so we're connected to our Elasticsearch index on the cloud. We can see it's a 7.8 version. And now I also have a CSV with NYC open data about restaurant health certifications, I believe. So we're going to load that. This is kind of what it looks like. If you're familiar with Pandas, this probably looks pretty familiar. You can see that the column names are really large. They're all uppercase, and they have spaces. We're probably going to want to change that. It's only 40 meg, so it's not exactly a huge data for like DataFrame. But I didn't want to hammer my machine while I'm essentially uploading already with this video recording. So this is just a couple of operations to rename the columns to make them look a little bit more like actual Python. And then as you can see, they actually have latitude and longitude. So we are going to combine those two columns into one column called location and provide the latitude and longitude so that we can essentially use geopoint queries in the future. So you don't want to have these two to be separate. You want them to be together. So that's exactly what these two are doing. We're taking the location, and it's going to be the sum of latitude and longitude with the comma between it. And then we're going to drop the latitude and longitude columns because we don't need them anymore. And then we'll look at what our data frame looks like. So this is kind of the steps that you would do when you have a data set and you know that you're going to want to put it into Elasticsearch. You can kind of move things around a little bit to make them work a little bit nicer with Elasticsearch specifically. So now things look a little bit better. There's no latitude or longitude, and we have a location, which is great. So now we're going to import that data into Elasticsearch. I'm actually going to start this because it might be a little bit slower now that I'm actually live streaming right now while I'm doing this. So my upload might be a little bit impacted. But OK, so this function essentially takes that data frame that we had from above, and it takes the client that we defined earlier as well. And we just hand it, this is where I want my data to end up in an index called NYC restaurants. And now this data here, it's detecting on the Pandas side, it's saying that a zip code is a float, which by default, when you import a CSV from just like a CSV into a Pandas data frame, it will say it's a float. And so we don't want our zip codes to be floats, obviously. There should be like an integer or something like that. And so we're going to override that to be a short because it's just a small integer. And then because DBA is an object type, the default string type will be keyword, just because we don't want to have text on every single short string. It's just a lot more to index. Instead, we default to keyword for string. And so if you want to do full text search on a string field within Elasticsearch, you should override it to be text. So DBA is a really poorly named column, but it's actually the name of the restaurant. So in the future, we're going to want to do full text search on that. And then the last one that we were working with a little bit earlier is the geopoint. So we want that to be a geopoint, not to be a string. So this is essentially just saying if that index already exists, which it probably did because I tried this out a little bit before this, we should delete that old index and replace it with what data we have we're providing now. So that essentially we would have this, if you wanted to just add data to that index. So let's say you had a CSV earlier, uploaded it, and now we have some more data. You can change this to be append, and it'll just append that data to that existing index. And now ES refresh, essentially this will call the refresh API on Elasticsearch. This is nice if you are going to be using this data like right away. You wouldn't necessarily need this if you're kind of just streaming data to Elasticsearch from a source. But since we want to use this right away, we're going to call ES refresh to basically say, hey, don't return until my data is actually indexed. Otherwise, there's like a potential where we upload this data and then we immediately query it and Elasticsearch hasn't gotten finished indexing everything. This should happen really fast, but on larger use cases, this might be a problem. We don't have that many frames. We only have 200,000 rows essentially. So now this returns back an Elant data frame. So this data frame, the data is not local. It is in Elasticsearch on Elastic Cloud right now. And so if we call info, it'll tell us everything about this data frame. The thing to note is this is only 80 bytes as opposed to what we had up here where it was 40 meg. So it's a lot smaller. The data is not on the machine. It's all in Elasticsearch, and we're essentially just querying the mapping to see what the data types of these objects are, and essentially what the columns are as well. All right, so now let's look at what type of mapping was generated by Elant. So you can see all of these keywords, PBL, and where are the ones? DBA. So DBA got that text override, and location got the geopoint override. But all of these other things like score, which was a float before, are now a double in Elasticsearch. Zip code got this short. And as you can see, a lot of the strings that we had are all keywords. So that's the default. OK, so now let's start trying out some APIs. So we have the shape API. People will probably know that. So there's 25 columns, and we have almost 20,000 rows. So this will use the count API behind the scenes. And so now you can see this data frame actually implements a lot of the APIs that are really familiar for people with Pandas. So I'm just going to run through those. Head, you can see it outputs really nicely, just the same way that a Pandas data frame would, the rows and the columns. And then columns, you can see all the columns. It outputs an index the same way that a Pandas data frame would. You can access columns into series. So this will show the exact same way that a series would for a Pandas data frame. You can see some of those values there, though we'll be searching on those in the future. You can also use slicing the same way that you would normally. And there's some operations you can do as well. So like grade is in. So this selects any rows that have a grade that is in either A or B. People familiar with Pandas are just like, we already know this, and that's totally fine. I'm just showing off that it's possible. And so let's peek a little bit behind the curtains on what's actually going on here. So I'm going to take that query that just occurred, and I'm going to call this method ESInfo. So what that's going to do is it's going to tell you what is actually happening in the background. So instead of just providing this API, you can also do ESInfo to kind of see what the task graph looks like, what is the query that's going to happen, what columns I'm going to get back, what data, data types is Elant assuming for my results. So if I print that out, you can see here's our index pattern. So NYC restaurants. So you'll note that it says index pattern. So you can actually provide, if you open up a data frame yourself, you can provide a pattern instead of just a single index. So if you have logs, for instance, you'll have, typically the use cases you have ILM, index lifecycle management. And so you'll have a whole bunch of different indices with potentially the time. And so if you did the prefix of that and then like an asterisk, you could search over all of those instead of just a single index. And so that is really powerful. I would just say make sure that each index has the same mapping. Otherwise, Eland will complain and say, hey, I can't actually build a column structure with this because some indexes have this column and some don't. So just be aware of that. OK, so the index field is ID. That's totally normal. And then we have all of this information about what the type and whether or not it's aggregatable and what it looks like from a Pandas perspective and what it looks like from an Elasticsearch perspective. So this is per column. And then down here, we also have the operations. So this is the task graph that I was talking about. So we have a Boolean filter with terms, a terms aggregation. And then it's using the grade field, and it's looking for both terms A and B. And you can see the query body here, and there's no post-processing happening. So post-processing are things like if I were to do tail, for example. Let's look at what tail would do. So tail is an interesting one because we're looking for the last elements in the data set, but you can't like say to Elasticsearch, hey, I want the last 10 very effectively without first grabbing the count. And so if I were to run this, you'll get the last 10 as expected. But then if I do esinfo, just to show off the post-processing, and let's print this out so it's actually pretty. OK. So post-processing, we're sorting by the index after we grab the last 10. So essentially, we're asking for the last 10, and we're sorting in a descending way. And then after we grab those values, we're resorting the other way so that they look properly. So yeah, there's a lot of stuff happening behind the scenes to make sure that your data looks exactly the same way that it would from a Pandas perspective. So the other thing that Elasticsearch is really good at is aggregations. A lot of the aggregation APIs are implemented, so median, mean, max, min, variance. There's more that are implemented. I just grabbed a couple, and we are just going to aggregate across the score column. So that looks kind of the same way that it would for a Pandas aggregation. And let's see what's happening behind the scenes here. So if I run that, oh, well, I won't be able to do that. Yeah, I won't be able to do that, will I? Dang. OK. Yeah, because so the aggregation, when it does dump to the Pandas data frame, we can't grab the esinfo. That's a bummer. I'll have to, maybe there's a way. I can show that a little bit later too. So yeah, aggregations all work the same way that they would. And you can actually do, if you decide to do like describe, where it'll show the entire, like all the aggregations that are possible. This is kind of the same way that Pandas would look. And you can kind of do this across the entire data frame as well. It'll do a lot of aggregations. So like all of the numerical columns will have these aggregations available. OK, so another thing you can do with data frames is you can do plotting. And there's actually a lot more that we're going to be doing here, but this is just like a basic example. So we're going to build a histogram of the score with PyPlot just in the Jupyter Notebook. You can see that kind of looks the same way that it would with a Pandas data frame. And anywhere that you can really like throw a Pandas data frame into an API, essentially, you can use that. There's actually another talk where we talk about how to integrate plotting on the Kibana side with Elant specifically, and how to like build plots out of Elasticsearch data. And you'd be able to use like Kibana for, I think Kibana Canvas for visualizing that. So that's an interesting talk. I can try to find a link for that. OK. So now we can use that really magical ESQuery basically method that we got earlier. So we're going to do a geodistance query, a distance of 5 meters from this location. And now we can see kind of what this data frame would look like with this type of filtering on it. So we can have a whole bunch of restaurants that are all within a certain location of this point. So if you had a point that you were searching, for example, oh, I only want data that's around this area, you can say, here's my point, I want this distance, and that'll filter the data frame that way. And as you can see, so this has 20 rows. And so if we increase this to 50, we should get more rows. Yep, 41 rows. And then we're also going to use ESQuery here to do a full text search. So DBA is the name of the restaurant. We're looking for restaurants that have the word red in there. So we can run that. And you can see Red Hook Lobster, Red Hot, all of these names have red in them. And you can do even more complex examples with full text matching. You can have analyzers. You can have all sorts of things here. I would recommend looking at the Elasticsearch query DSL documentation for some of the more powerful matching that you can do. This is just an extremely simple example on what is possible with Elant. And so now here is basically you can chain these things together. So the way that, because the task graph is immutable, and whenever you add something to it, you're essentially creating a new data frame, you can change you can like basically, if I were to grab this one little segment and then put it somewhere and assign that to a variable and then use it later, it would remember the previous things and it's immutable. So it just performs the same way that a pandas data frame would. And so this is essentially querying the data frame saying, I want all of the rows that have a grade of B, and then I want to grab 100 of them, and then I'm going to pull them to a pandas data frame. So this is essentially showing off that you can pull to a pandas data frame if there's something that is not implemented on the ELANT side and you need it for your operation. You can pull to pandas, and then it'll end up being a pandas data frame. So this is a pandas data frame, and all the data looks very similar. And there's only, let's see, 100 entries because we sampled 100. So that would give you 100 random entries if you don't know what the sample thing does. OK, and so that's kind of the end of the DataFrame demo. So I also have a machine learning demo, but I'm going to switch back to my presentation before I continue with that. I don't know if anyone's asked any questions yet. I can't really tell. I'm actually looking at a Google Doc right now. All right, machine learning. So machine learning is also the other component of ELANT. So to use ELANT with machine learning, you also have to have like an Elasticsearch cluster that has machine learning nodes. I showed a little bit earlier on how to enable that on Elastic Cloud. I actually should maximize this if I can. No, it's not giving me to. Oh, well. So if you have an Elasticsearch ML model, you can run predictions on like an existing machine learning model that you have within Elasticsearch. And you can also import a model that's either written in XGBoost or scikit-learn into an Elasticsearch cluster, and it will use the native machine learning technology there, essentially. And so you can run your predictions on either locally, like if you train an API locally with scikit-learn or XGBoost, and then upload it to Elasticsearch, and then you can switch it to be either like an ingest processor or just appending values or things like that. So I'll show a demo about that. And then it uses this API to feed data into this inference model within Elasticsearch if you want to exercise one that's already in a cluster. So these are the models that are supported currently for serialization into Elasticsearch. You have both basically classifiers and regressors, some of the basic ones from scikit-learn and XGBoost. And potentially we'll add some more in the future, but currently we have inference models that can do classification and regression, so those are the ones that we support. All right, let's get a demo. So you'll have to go easy on me because my machine learning is a little bit not as strong as my just general Python knowledge. So there could be things that are completely wrong here, but I think that this is pretty good. It's just a really simple machine learning demo on how you can train a machine learning model with scikit-learn locally on a data set and then get results from that. And then after you get results from that, upload that into the cluster and then say, OK, I want to now run this against data that's coming into Elasticsearch. And then eventually the normal thing that you would probably do with an inference model is append data through an ingest processor or something like that. So I'm going to use one of the basic scikit-learn data sets. And I'm also going to just use a decision tree classifier. So I'm importing those. And I'm going to load the wine data set. I found that data set has a lot of nice data that would make sense for like an Elasticsearch use case. Essentially, it has a lot of feature names, and it's not really to do with images. So a lot of the data that they have here is to do with images. And so if I print that out, and what we're doing here is this is essentially just pulling the data and the targets that we'll be using for training. And so the data set specifically outlines that index 10, 80, and 140 are for testing. So those are the three types of wine that we're going to be like testing our data set on. And so we'll pull those out of the training data and use them later. And we're initializing our classifier, fitting our training data, and then we're going to predict against the data that we're giving as an input, and then we're also going to print out what that expected output would be. So we'll run that. So this is like our feature names. You have alcohol content, malic acid content, ash content, all of these different things that are essentially, they took these readings from each individual wine, and then the 3 different classifications of wine. I'm pretty sure it's like white, red, and then something else. And then these are the outputs that our model predicted for the given testing inputs. And then these are the actuals. So it did a pretty good job, as expected. OK, so now we have that model saved under SK classifier. And now what we're going to do is we're going to import that model into Elasticsearch. So what this will do is it will pull apart the model, grab all of the values that it has within the model, and essentially serialize those into one giant Elasticsearch query to create an inference model. And then once that inference model is created, then you'll be able to use it and exercise it either as an inference or an ingest processor, or in another way if you want to just like test your data against it. So here we have the ES client from before. So this is going into our Elastic Cloud cluster. We give it a model ID. So this is something that we'll be able to reference later. If you want to delete it, or if you want to add it to an ingest processor, you'll be using this exact classifier here. And then we hand it our model. So that's our SK classifier that we trained above. And then we're going to have the exact same feature names as our wine. And then we're going to overwrite if that model already exists. So this will essentially just delete it if it exists already. Then we'll just delete it and replace it with this new one. So you got to be careful with this. If you have a model and this ID already, and you don't want to delete that model, then you should probably choose a different ID. And then, so this, we're just essentially turning on logging, debug logging, just so I can kind of pull back the curtain, prove that this is an Elasticsearch query and not actually we're just running the model locally. And I also want to kind of visualize what the input and output from this predict is. So then we're taking this ED classifier that we just defined, and we're calling predict on the exact same data. And we're going to print out the target, and we're just going to show kind of what the inputs and outputs are. So let's run that. So this is what the debug output. The red is totally fine. It just means it's debug output. Nothing went wrong. And here's our predictions, and here's the output. So obviously that's not surprising, given that we're literally serializing the model and then uploading it to Elastic, and then we're taking the exact same data and sending that to that model. So obviously it probably should give the same results. But so the interesting part is that used a pipeline processor. So if I grab, this is incredibly hard to read as it is right now, but I'm actually going to pull this here. And so I can pre-print it. This is why I needed this earlier. So here's our 3 inputs that we are sending to Elasticsearch. So it has all of these different values. And then we're specifying that wine classifier as our model ID that we want to use as our ingest processor to simulate what it would look like when that ingest processor and that inference model are handed these data sets. So if you were ingesting documents, you could like append what your classification of that wine, that specific wine. And this obviously you can change this to be whatever you want, but you can say, okay, I'm not able to determine what the classification of the wine is on the ingest side, but then with this machine learning model, I'm able to kind of just determine it from these values. So that's what the input is. That's the request body. And then this is what we're getting back from Elasticsearch as a response. I'm going to quickly print that out as well. So now we're getting back. Here is our ML inference model ID is giving a predicted value of 0 for this document, and then 1 for the second document, and 2 for the third document. And that's where we're deriving these values from. And so obviously, when you're using an ingest processor, you can append that classification value as opposed to just returning it in an array. So you can actually append that to the document if you were to not be doing this in kind of like a simulation style. All right. And that is it for the machine learning demo. Switch back to the presentation. And that's it for me. That is all I have. Now I'm just kind of open for questions. Hopefully that was helpful to everyone. I will note that Eland is in beta, but we're trying to get it to be GA pretty soon. And the APIs are pretty solidified, so I wouldn't expect anything to change anytime soon. Or nothing large will be changing. It's because it's essentially the Pandas API. So if Pandas isn't changing, we're also not changing.
Yeah, if you have any questions, just put them into the chat, or I think if you want, you can also just speak, enable your video, whatever you prefer. I think I have 2 questions, actually.
Sure.
before we see any other question there. So feel free to type and take your time. One of the things is you mentioned scripting that is supported. I suppose that scripting is just supported as part of the ES-query method within the examples, or was there anything else specifically supported?
Sure. So what you can do is, I'm going to do this live. What you can say is, okay, if I want to compare a column to another column, so like, I'm trying to come up with a good example where the score is greater than, maybe I can do like score of a certain other one, potentially. I'm gonna have to look at my thing. Let's see, what's another thing? I can do if the score is greater than the zip code, which it shouldn't be ever, or the zip code's greater than the score. So that one might actually, this is obviously not realistic, but if you, for instance, have two fields that sometimes they're greater than the other, sometimes they're not, and you want to filter on that, you can do this, and this will actually write a painless script for you, which does this query in the background. So here you'll see this painless script was written for you that does this numerical comparison. And it can get more complicated than that. That's just kind of like a simple little example. But where you can do these types of comparisons, you can do not equals, you can do, there might be regular expressions in there too. So yep, if you do those types of comparisons, it will actually write the painless script for you as opposed to you having to write it yourself. Obviously, like you said, you can just directly use ES-query if you want to write some really complicated painless script that's not really representable from the Dataframe API. That's totally fine too. That'll work just as well.
Cool, thank you. Yeah, there's one question in the chat. I would just recite it over here. To clarify, can you use Eland just the pandas bit without using the Elastic ML backend?
Yeah, so you can use as long as you have an Elasticsearch cluster where your data store is, you can do self-hosted, you can do Kubernetes hosted, anywhere you want. It doesn't have to be Elastic Cloud. So what you can do is just point it at that Elasticsearch index where I had above. It doesn't necessarily have to be a cloud ID here. So you would configure your Elasticsearch index that you want to use, or Elasticsearch instance that you want to use here. And that could be your host name with your API key authentication, and it'll work just the same. So it doesn't have to be Elastic Cloud.
Yeah, that is basically just a regular Elasticsearch Python client being instantiated there. So you can put anything in there you want.
Right. Anything that the Python client will work with Eland as well.
Yeah, there's a follow-up question if you're going to share your Jupyter notebook and slides.
Oh yeah, no, I'm going to be posting the slides and I'm putting them probably on the documentation since this is more up to date than some of the Jupyter notebooks that are there. So they'll be in the documentation on the read the docs. And I'll also post the specifically like the data sets and the code and everything that I'm using as well. So if you wanted to like perfectly recreate this Jupyter notebook, you could. Yeah.
Is there, apart from that, any biggish features coming up to the roadmap until the 1.0 release or anything more support for the machine learning integration or anything like that you may want to talk about?
So the big feature that we're working towards is making the APIs work a lot better with time series data, because that's kind of like the big data use case where you have all these massive amounts of logs and you want to be able to plot against like a time series graph. Currently, that doesn't work super well in Elant just because you can't set your index to be a date time essentially. So those are like the big feature that I would say is coming very soon. And then group by. So that kind of goes hand in hand with a time series where you can do either bucketing. So like if I wanted to show off, based on the borough that this restaurant is in, what is the grade distribution per borough? You can't do that right now unless you pull to Pandas itself. But obviously that should be possible. So bucketing via group by, and then also time bucketing via group by, and better support for time series data. I would say those are the big features that are coming soon.
How much of the Pandas API is implemented in Eland? Or I think we can probably revert the question. What parts are potentially missing, right?
What parts are potentially missing? So actually we have a list, which may not be 100% up to date because there have been a couple of things. Sorry about that. it is in the way, but if I go to implementation notes and supported APIs, so this is a part of the documentation. Essentially, this list is all of the APIs that we were able to pull from Pandas, and it gives just a yes and a no whether or not it's implemented. So some of these are out of date. So like STD, standard deviation, we actually have implemented that. This just hasn't been updated. But this is a good place to start. I would say that like a lot of the APIs that aren't implemented that people would use frequently are things like iLock. So iLock isn't implemented, lock isn't implemented, essentially just because it doesn't map to a good concept in Elasticsearch, like getting a document at an exact row, like that's not really something that Elasticsearch is very good at, and something that you might not want to do in Elasticsearch. Instead, it's more about like aggregations and manipulating data, visualizing, making graphs, things like that. So yeah, there are some APIs that aren't implemented, but for the most part, the ones that map to a good concept within Elasticsearch are implemented because it's not too bad to map them.
Dask allows users to visualize task graphs via the .visualize method. Is there a way to dump the task graph for debugging?
So the ESInfo method would be the one that I would recommend. And I know the output is it's a little bit verbose. And so there's definitely been some questions about like, hey, we want to be able to see better what's going on in the background. So that API isn't useful except for just visualization purposes. So there might be some changes to that later on, especially because with indices that have tons of columns, it especially just makes a huge mess of the screen. So we'll probably try to make better sense of what's actually happening with the task graph in a future version of ESInfo is my guess. But yeah, ESInfo right now, you can visualize the task graph. It doesn't do, I'm actually not seeing task graph visualizations yet. That might be a good springboard point potentially for some inspiration there, but I'll have to investigate that more. Thank you.
What versions of Elastic is supported by Eland? Do you need an absolute minimum version because you're using certain features?
Yeah, so Eland supports 7.6 and above. And that's more just because like the full feature set of Eland is available to be used on 7.6 and above. So like some of the machine learning features, like they might not have compatibility there so a lot of machine learning features are not GA. And so for us to support, if there's any changes, we can't like guarantee support. But what I will say is that the Dataframe API should work on any like 7 version of Elasticsearch. And if you have a specifically configured version of 6, it'll probably work. But I'm just not going to say that we support 6 because 7x is what we support currently. We just use the version 7 of the Elasticsearch client. So.
Is it possible to increase/decrease the parallelism across larger clusters with larger data sets? I'm not super sure if this question is more about getting the data, like using slices when using search or scroll search, or if it's more about handling the data in Eland. So maybe you can answer something, or Jared can sort of specific with regards to the question. I would ask to be more
specific, but what I would say is that when you're grabbing the data from Elasticsearch, it uses scroll. Because obviously we don't know going in how much data is going to be pulled when you essentially do this query. So yeah, we do use the scroll API. So anything that you can do with the scroll API is what will happen essentially.
When do you think the time series implementation will be complete?
So it's all about priorities. We're hoping to have it out in the next few stack releases, I believe. This is kind of like the last major hurdle before we can say, hey, we're GA. So yeah, the time series is definitely the highest priority for us right now in the project. Yeah, I don't have a great like time estimate. So probably within the next few stack releases, it'll be completely done. So the time series.
I'm going to call it a day for today. Thanks again for Seth for talking about this.
Thank you for all the great questions.
Have a good day, everyone.